In this question, you've just been asked to find the answer, but they say in terms of A, B, C, or D. So any integration problem that has an inner function, we can use u sub. In this case, u is 1/2 x. U prime is 1/2. And so our integral will be sum upper and lower integration limit f of the inner function u du divided by our u prime. In this case, when we divide by 1/2, we can replace that with multiplying by 2. Now I need my limits of integration. Well, if u is 1/2 x and my lower x is -6, 1/2 of that is -3. Now we'll put the upper limit in. The upper limit was 2. So 1/2 of 2 is 1. So what we really want is 2 times the integral from -3 to 1 of f of u du. Okay, I'm like, well, I don't know how to do that. Like, I don't know what f is. But you have been given this piece of information right here. G prime of x equals f of x. And here we're being asked for the integral of f. So if I integrate this f, I would have to integrate this g prime. And we know the integral and the prime undo each other, and so the integral of f of x is really g of x. So that just means this antiderivative is g. So now when I do this, I have 2 times the antiderivative of f. Well, that's just g of x, a lower limit of -3, and an upper limit of 1. So that means I can write this as 2 times g of 1 minus 2 times g of -3. And we still couldn't go anywhere except that we were given all this information in the problem statement. So we know g of 1 is c. And we know g of -3 is b. So we're looking at 2 times c minus 2 times b, or if I factored out the 2, I would have c minus b, both times 2. Either of these are the same. Neither is any better than the other. But this is that key piece. The antiderivative of f is g, and that goes into our fundamental theorem of calculus right here.